All right, here we go. Let's start it off with numbers 1 through 6. How we doing today? Whenever you watch this, it's a great day. It's a great day. Here we go. So the first one, number 1, asks us to rewrite the equation in exponential form. Remember exponential form. I've called it the circle of life. You want to look at this log and think about, all right, what's the base of our log here? Okay, the base of our log is 10. That means the base of our exponent has to be 10 as well. Okay, circle of life. 10 to the z equals 42. Now, obviously, that's all you got to do. You got to just write an exponential form. Okay, you don't have to go anywhere, do any more than that. All right. It says rewrite the equation in log form. Well, I ask you again now. Now we're going from here to there. So we're undoing the circle of life. Okay. So in number 1, I asked you what was the base of the log. The base of the log was 10. So the base of the exponent is 10. Well, here the base of the exponent is 8. So that means the base of our log is 8. Okay. The z came from the other side of the equal sign. So we're undoing our circle of life. So the x, and then our answer, oops, I was going to write 42. Our answer is 24. So the way to check your work, think about circle of life. 8 to the x equals 24. That's exactly what I wanted. Howdy doody. Howdy doody. Okay. Different. All right, here we go. So we're talking about graphing exponential functions. All right, remember our key features here. Okay. Our key features are 2 points that we know, and then our horizontal asymptote. Okay, so our first point that we know is on every single exponential function is 0, 1. All right. The next ordered pair that we know is 1, whatever our base is. Well, our base of our exponential function here is 2, so it's going to be 1, 2. And our asymptote, prior to any shifting, remember, is always y equals 0. All right. Sorry. So I want to look at my original. Okay, what is the plus 3? Remember, I think about this plus 3 as kind of being in parentheses. When it's inside, when it's next to our x, when it's inside parentheses, remember we do the opposite. So we would think we would go to the right 3, but remember, in fact, we go left 3. And the plus 2 on the end makes us, or shifts us up 2. So 0, 1, which is right here, moves left 3, 1, 2, 3, and then up 2, 1, 2, to that point there. So negative 3, 3. So this became negative 3, 3. Now I'm writing this in red down here so you know where the actual point is in case it's hard to tell. All right. You don't actually have to write this part, okay? But it's very helpful that you start here. So I don't like these always, but I would like you to start with these 3 key features and then shift it based from there. So knowing your key features is important. All right. Start at 1, 2. Shift to left 3. 1, 2, 3. Up 2. 1, 2. So I'm at negative 2, 4. So this became negative 2, 4. And remember what we said about our asymptote? The asymptote is only affected as if there's a vertical shift. All right, if there's an up and down shift. Here, our shift was up 2, so my asymptote is going to be at y equals 2. So my new asymptote is y equals 2. Oh, look, I can just plug that in right here, y equals 2. Okay, and then connect our dots here, and it's going to look something like that. Domain. Domain, remember, refers to our x values. I can plug any single x value in and it'll spit out a y value. So my domain is negative infinity to infinity. All right, my range is different. Remember, your range is your y values. Okay, your range goes from bottom to top. All right, so I think about what's my lowest possible value for y. Well, if I go from the bottom and I start, I hit this asymptote. So at that asymptote, remember this asymptote always corresponds with our range. So our range or asymptote will always correspond. You don't have to worry about the intercepts. We're just going to X that part out, okay? In the past, I've done the y-intercept, but I just want you to be able to graph this part, Okay, now when it comes to your actual assessment, it's going to be hard to have you graph, or maybe we'll figure out a way. I'll let you know more on Tuesday about that. But you will have to identify your domain and range and your asymptote from graphs, okay? From this function or from the equation, all right? So basically what I'm saying is I may give you this and say, all right, identify 1, 2, 3 without the actual graph itself, okay? All right, so let's look at this one. We have 3 as our new base here. Well, still, our first order pair is 0, 1, okay? Our second order pair is 1, well, since our base is 3, it's 3. And base, remember, is our number right there. It just so happens that this is a 3 as well. I don't want you to get confused by that, okay? And so I guess that worked out here. It was also a 2 over here, all right? But the base is actually this number here, okay? And our asymptote is still y equals 0. Okay, so now we got to think about how this shifts. Remember, if it's with the x, it's the opposite. I would think I would go to the left, but actually I'm going right 1. And then on the outside, I do the same, so I'm going down 3. So I start at 0, 1. Okay, 0, 1. I go right 1, down 1, 2, 3. So I'm at 1, negative 2. So this became 1, negative 2. All right. I start at 1, 3. Go right 1 and down 1, 2, 3. Oh, sorry. 1, 2, 3. So 2, 0. Remember our asymptote only changes if there's a vertical shift. There was a vertical shift on this one. Our function moved down 3, so it's going to be y equals negative 3. And I'll make my horizontal asymptote there, or draw it in. Fill it in here, y equals negative 3. Connect my dots. Holy buckets, here we go. All right, so holy buckets, here we go. So, all right. Domain, I can plug in any x value, I'll get out a y value, so negative infinity to infinity, wow. Range always corresponds with my asymptote. My asymptote's negative 3, so my range is negative 3. Holy cow, what is that? That is not a 3. Negative 3 to infinity. Intercepts, remember, we can just forget about it. Forget about it. Okay, forget about it. All right. Wow. So I'll go back to that for a second so you can make sure. Basically, just give me some time to have a sip of coffee. Here we go. Number 5 asks us to expand the log completely. All right, so in number 5, I want to think about what operations are going on here. I have a 14, an x to the 5th, and y to the 4th. What operation is going on between these 3 terms? Well, there's multiplication in between those 3. So remember, our log properties, multiplication becomes addition. So I want to expand this as the log of 14 plus the log of x to the 5th plus the log of y to the 4th. Am I done? No, I can expand it. Remember, whenever we see an exponent within a log, I can drop it like it's hot to the front. So this will become log of 14. That doesn't change. Plus, now I got the 5 out front. 5 log x plus 4 log y. Wow. That's sick. That's our answer for number 5. Holy buckets, we got one more. I got one more to do. I'm gonna really enjoy this last problem. Take my time with it. Here we go. Last one, number 6. All right. So in this one, in my numerator, I have 11w, and I have multiplication going on there, and I have multiplication going on there, but I have this big division bar. Okay. Remember what division means. I'm going to ignore this multiplication for a second and just talk about the division. The division, if multiplication means addition, and division must mean subtraction. Think about this fraction bar. It looks like a subtraction symbol. So I'm going to write this as a log of 11w minus the log of xy. Okay. Now, like I just said, multiplication is here and multiplication is here. Okay, so because of that, I'm going to expand my first log of 11 plus the log of w. All right, now this next step, okay, can be a little tricky. All right, I want the xy to be in the denominator. So what I can do is I can subtract and put parentheses and make that addition. But when I write my final answer, I want to think of this as being -1 here. Remember, if you don't see, like if I have x, I can imagine there's a 1 in front of it, just an imaginary 1. All right, same idea. If I'm subtracting a parentheses like this, I can imagine that there's a 1 attached in front, and really just I'm distributing my negative. So it's the log of 11 plus log w minus log x minus log y. The double subtraction like this tells me that x and y both need to be in my denominator. All right, and then this will be my final answer. If you're confused on how I got that in the review packet, I just kind of skipped this step. Okay, you are able to skip this step. That's totally fine. I'm not going to be mad if you do that. Okay, but yeah, that should be it. Hopefully this helped. Let me know. Let one of us know if it didn't. Have a great day. Deuces.